Um, so we're going to continue with uh, step 3 on page 5-4, sketching the open-end profile. So we're going to do a new sketch. I'm going to put it in the top plane. So you're going to click top plane over here on the left. Oops. And then you're going to click sketch in that little box that comes up. Let's also do normal to that plane so that we can see what we're doing. And then since we're sketching on this top plane, it's going to be on this shape we just did, but it's going to kind of float within it on that plane. So let's see. Under view display, let's see, I think that's this one. They want us to select hidden lines visible mode. So that's going to be hidden lines visible. It's going to be the fourth one down there. Does everyone see what I'm looking at here? Okay, cool. So you guys are all already kind of done this part. I'll just go through it quick then. If anyone has questions as I'm going through this, just feel free to stop me. So we're going to do a center line. It's going to start at the origin. It's going to go, it's going to be horizontal-ish. There we go. And then do a couple of circles here. They're going to start on that center line. Okay. So they're co-radial, which means that they have the same origin. Let's see. And they're also going to be co-radial with this little cutout part of this original shape here. It goes co-radial. Alright. And then we're going to do a tangent arc. And that's going to go right here. Oh. Wants me to select an end point. Oh, okay, that's because I'm doing a tangent arc. We want a 3-point arc. So we're going to go Now we're going to trim these away. those two to be tangent. And then I also want these two to be tangent. Alright, is everyone caught up to this point so far? Anyone not caught up? Nice, alright. So, let's see, I think I still need to trim that one line there. Let's see, actually, before we do that, let's go back to the top plane. Go back normal to where we were. Oh. Alright, sorry about that. Let's move me out of the way a little bit here. Am I still... I'm kind of on the screen now, but hopefully that's a little better. Are you, do you have any questions so far, or are you kind of with me? Alright. Trim that. Okay. Alright, so yeah, all I was doing was I was sketching this shape. I trimmed away the extra parts of the circles there. And then I dimensioned everything. So like this center point of this little tiny arc here to this center line up here, this is going to be the dimension. And so the last thing we got to do, let's go back to the top plane. Let's go normal 2. And we're going to add one more relation. We don't want top plane in there. We want this line and this line collinear. And it should be fully defined now. So, alright, so we've got this little arm on here. We're going to revolve that. So, and the axis is going to be this center line again. The direction is mid-plane. Alright. And then 75 degrees. And we're going to click OK. Alright. So now you should have this with this little cup shape on the end here. Let's make sure everything's fully defined. Yep. So then we just want to mirror that revolved feature. So we're going to click the mirror feature up here. Why am I not seeing it? Here it is. We're going to click mirror. It's going to be front plane for that first thing there. Second box is going to be revolve 2. So, and then you'll be able to see it show up in yellow here. It's like a preview of what it's going to look like. And we're gonna click OK. So there's our shape. Now mine is not showing up solid like it was before. I think that's because I've still got this display thing here. So you can make it solid again and you'll be able to see the whole thing. So that was because if you remember earlier we did hidden lines visible, so it's going to show up like that. And then of course you can always go back to this. You can also view it without any of the lines, which is kind of cool. Alright. And then we're going to add some fillets to that. Oops. We're going to do these two edges here. Make sure you're clicking, when you click that edge that you want is orange. You don't want anything else. That means your mouse is in the wrong spot. So you're going to do that. The radius is 0.08. 0.08. And click OK. Pretty simple. And then it just has us doing some more of those in different areas. Looks like they want us to do these edges here, so we can go ahead and do that real quick. Is it? I'm trying to see where the arrows are pointing there. I think it's going to be this edge. This edge. Outside edge. That's probably because of the... Did you put in the radius as 0.08? Okay. No worries, that'll do it. Yeah, so it should be 0.08 and then... Cool. And then the second one is going to be 0.015. And you'll see those little edges there all show up. Okay. Yeah. No worries. It's kind of hard to see in the book where what they're pointing at. Yeah. All right. So that's it for that exercise. So you've got this arm here. Now, one of the things that's going to be on the midterm next week is going to be how to find the mass of a part that you're modeling. So I'll show you how to do that real quick. If you go over here on the left in your menu here on the left, you'll see material not specified. You can set that to any material you want. On the midterm, I'm pretty sure we're going to have it be brass. So you're going to right click that, you're going to click edit material, and in here you can pick anything you want. So I think on the midterm it's gonna tell you what you want it to be on the midterm so that everybody has the same, so it's clear, so there's no question. But I think what we're gonna do is I'm not seeing it. Not under steel. It's under copper alloys, and you're gonna pick brass right here. And then click apply, and you'll see it looks like brass. It's kind of cool. You can do all kinds of materials in here. You can do wood, make it oak. It's kind of weird. But you can do all kinds of plastics. You can do all kinds of different stuff. Anyway, on the midterm, it's going to be brass. You're going to click apply, and then it's important that you pick the right material because whatever material you pick is going to have a different density, right? So once you have that, then you go over here to the evaluate tab, and you're going to click mass properties here. And it's going to tell you density 0.31 pounds per cubic inch. So the mass of this particular part is 0.23 pounds. The volume is never going to change on a given part unless you change the size of the part or you change some dimensions or you go in there and add stuff. But for this particular part, whatever the material is, the volume is always going to be the same. The mass is going to be different because the density of the material is going to be different. So that's probably pretty basic. You probably are all like, yeah, okay, we get it. But just want to make sure that that's super clear. So so yeah, on the midterm, it's going to ask what your mass is, and the reason we're asking that is because I'll be able to tell if you made the part correctly. If you missed something, if you didn't add a certain feature, obviously the amount of material there is going to be different, right? So your mass is going to be different. So so that's the main reason for that. Obviously, that's not going to be 100% of your grade, but that is going to be a big percentage of your grade on the midterm. It's also going to be based on, is everything fully defined? Did you actually model the part that, I gave you to model? And I'm going to look at what you did and grade it based off of that. So that being said, does anyone have any questions so far? These are just exercises so that you can see how to do everything. So I'm not going to ask you to turn these projects in, but it is, to your benefit to practice, because otherwise you'll have a much harder time on the tests and with the homework assignments that you get. So, if you actually go through and do the exercise, then you'll remember more of this, more of the processes to get a certain part. The other thing too is practice. Like the thing about SolidWorks is that being good at it really comes down to being able to model things quickly and correctly. And using the software is, that's really all it is. It's just knowing the software like the back of your hands. So like, um, if you go to draw a shape and it's kind of a complicated shape, like that first assignment that I gave you guys, I know a lot of you kind of struggled with that and making it look like what it actually is, making it look like the drawing, but you you get better at that. So like at the end of the quarter, ostensibly, if you were to go back and try and draw that again, you would be able to do it much faster and it would turn out looking like the part and being fully defined. Um, just because, when you look at it, you're going to say, oh, yeah, that's this kind of arc, or that's this kind of circle, or I'm going to use this type of relation to achieve, these dimensions that I want. Um, so that's really what it is it's practice, and it just is going to make your life a lot easier. So, yeah. Yeah, no worries. So I'll go over it one more time. So in here, you're gonna see on your menu on the left over here, you're gonna see material. It's gonna be unspecified to start out. You can right click that and you'll see this this menu pop up. You'll click edit material and you can pick any material in this menu here. So on the midterm, what I'm going to do is I'm going to tell you guys I want you to model it and then make it this particular material. And so it's probably going to be brass. I think that's what's on there. But say it says on the on the midterm, I want 1023 carbon steel sheet. You're gonna pick that one there. Um, I'm gonna make it easy for you guys, and I'm just gonna make it brass. So, but it's under copper alloy, so you're gonna click brass, and you're gonna click apply. And then to find out what the mass of this part in that material is, you're gonna go to the evaluate tab. And you're gonna click mass properties up here. It's a little scale. And then it's gonna show density of the material is 0.31 pounds per cubic inch. Every material has a different density. And then the mass of this specific part is 0.23 pounds. And I'm going to ask you to put that in. I'm going to say on the midterm, you're going to model a part. And then I'm going to say, okay, what's the mass of this part? And you're going to enter the number. So yeah, does that make sense to everyone? Cool. All right. So one more thing, I think. Next week, we're going to start going over how to make assemblies. So I know a couple of you have tried that. You've played around with assemblies a little bit, but just keep in mind that's going to be something we go into more depth on next week. Let's see what the assignment is. There you go. All right. I'm going to go to your homework for this week. Let's see. All right, so your assignment for this week, I'm going to go ahead and publish that. It's going to be Lab 4. It's going to be kind of similar to last week. You're going to design whatever you want. It has to have at least 5 of the following elements, and these are all things that we've gone over so far, I believe. So it has to have at least 5 of the elements on this list. So you need to use hole wizard, revolve cut or extrude, circular feature patterns, shelling, ribs, fillets, draft angled extrusion, which we actually haven't covered yet. So only do that if you're feeling adventurous and you want to figure it out. Otherwise, we're going to go over that. But I'm sorry, you used it? Okay, cool. Actually, I think that's, let's see. If we go into extruded boss piece, I'm just going to open something else real quick. Okay. I think it's pretty simple. I think it's just if you extrude something, let's just use sketch 1 here. Okay, yeah, so this is a draft angled extrude. If you click this little sort of cone shape here, it's not really a cone, but you can extrude something so that it kind of angles outward or inward instead of just being a straight extrusion. Um, so like, let's see, I'm looking at sketch 1 here, which we already revolved, but um, let's make it 2, and then we'll make the draft angle 3 degrees. So you can see how it extrudes it at an angle. It's not just straight out. If I were to make it less of an angle, it's just going to look like it's straight. If it's 0, yeah, it won't taper at all if it's 0. So, but yeah, so the more of an angle you make it, the more tapered it's going to be. At a certain point, it's going to be so tapered that it doesn't actually end where you're telling it to end. But, and I think you can also do negative, so it goes the opposite way. Oh, maybe not. Oh, I remember how to do that. You go draft outward, so it goes the opposite direction. I think it got confused because I did too much of a draft. I don't think it's possible to go further than that for some reason. But anyway, so that's a draft angled extrude. So you can definitely use that. It's the same as doing a regular extrude, but you just check that one option there. Let's see. Ribs. Have we not covered that yet? Ribs are right here. So that's actually. Oh, really? Yeah, there's specific ways that you kind of have to use those. Let me see if I can find where that is in the book, and I'll just show you. Yeah, so chapter 6 goes over rib and shell features. We haven't really gotten there yet, but we can do that real quick if you want. I think this exercise is really easy. So, let's do a new part. And we're going to do sketch. We're going to do top plane. And it wants us to do this rectangle. I'm not actually going to dimension everything. I'm just going to go through quick so I can show you. So you're going to do an extrude with this shape. And it's probably going to look weird because I didn't actually dimension anything. So direction is going to be blind. And we're going to reverse it. So it's going downward from our sketch. Dimension is going to be 2 inches, which I'm just going to do 0.02 meters. Draft angle 5 degrees outward. All right. So they want us to do all these cutouts. Let me see if I can just skip to the shell part. Or the rib part, rather. So it's kind of like doing a shell, actually. It's going to cut out a shape, but it's going to leave ribs where you did your sketches. Um, so let's just go ahead and sketch on the top face here. Normal too. Looks like we have a circle. There's two crossed lines in the middle. Alright, and there's a couple more lines, but I'm just going to go ahead with that. So we're going to go rib, and let's see. Oh, you know what? They did an extruded cut already, so let's they did that on the last page. We're going to sketch on this plane. And we're going to do another rectangle. Oops, I did a center rectangle. So I want to start at the center. And we're going to do an extruded cut with that. Let's do that 0.015 meters. We're going to do the same draft angle. See if this works. Okay, nope. So I think I got to get rid of this middle part that I sketched before. Alright, so now we've got this extruded cut here. So now we're going to do a new sketch. We're going to sketch on the front plane here. And we're going to do this circle and the two lines. Alright. Now we're going to do the rib thing. Ooh. Alright. So we want this direction. We want 5 degrees. I don't know if it's going to let me do this because I didn't really follow the instructions, but you kind of get the idea. If you look at that picture, you can see what the ribs look like. And basically what you're going to do is you're going to do a sketch, and then when you do your ribs, you can select how high you want them to be and how thick you want them to be. It's like when you did your light switch covers, or your outlet covers. Some of you saw like they had reinforcements on the back. Ribs are one way to add reinforcements like that without having to, sketch the whole thing from scratch. You can say, okay, here's the outline, and I'm just gonna make these ribs in here, and it uh, comes out kind of looking like those reinforcements. So does that kind of make sense? Does that answer the question? Yeah. Okay. So yeah, if you are curious about how to use a feature, pretty much everything is covered in the book. So obviously, I want to try and go over as much of it as possible with you guys. But if there's something that I've missed or something that you have questions about and you can't get a hold of me or whatever, or we don't have time in class, if you look in the book, you look up how to do that feature. There's usually really good instructions, and you can go through an exercise and kind of figure out how they intended for it to be used. And I mean, obviously, I'm not saying that so that, to say, like, don't ask me or, expect me to go over it with you. I'm going to do my absolute best. But, if it's the middle of the week and you're playing around and you're like, oh, I want to use this in my lab, but I have no idea how to do it, then, that's always a resource. The other thing, too, is like, if you look up YouTube videos on how to use SolidWorks, there's like all kinds of crazy stuff out there. So there's one guy that, I yeah, yeah. I mean that one you can do all kinds of weird stuff with. It's a really interesting tool because like it's pretty flexible, literally and figuratively. So it's yeah, but it's also it can be tricky to use if you don't uh know how to use it. But there's all kinds of tutorials and instructional stuff. So if you're ever trying to figure out how to use a feature and you're not sure, you have it's not working for you or whatever. Yeah, there's all kinds of information online. So um, let's see. So what else is in lab 4 here? So mhm. Oh yeah. All right. So I'll mm, I'll shut this down and I'll come back. If anybody doesn't want to come back after this, you don't have to because we've pretty much covered everything. But I'll come back and we can talk about anything else you want to go over at that point. And I guess I'll talk to you as soon as the internet comes back on. So just keep an eye on it. Okay, cool. Talk to you guys soon.